It's my pleasure to introduce Howie. Howie has spent much of his career connecting communities, science and local development. A former teacher, broadcaster and counsellor, he has directed the Orkney International Science Festival for many years and has supported numerous community development projects across Orkney. He's also the author of Orkney, published in 2013. And I realised I forgot. See that was the cheat sheet. Yeah, I spend all this time putting these graphics together, and then I couldn't do them. So, sorry, Howie.
Thank you very much indeed for that kind introduction. It's an honor to be here, and it doesn't need me to say that we live in uncertain times, but I can say that some people have been saying this for a long time. Back in 1919, the playwright George Bernard Shaw wrote a play called Heartbreak House. The house in the title represented the Europe that had just emerged from the First World War. In the play, there is a moment when 88-year-old Captain Shotover, long retired from the sea and drinking a bottle of rum a day, tells his son-in-law Hector of the state of England. Captain Shotover. The captain is in his bunk, drinking bottled ditch water, and the crew is gambling in the forecastle. She will strike and sink and split. Do you think the laws of God will be suspended in favour of England because you were born in it? Hector. Well, I don't mean to be drowned like a rat in a trap. I still have the will to live. What am I to do? Do nothing simpler. Learn your business as an Englishman. And what may my business as an Englishman be, pray? Navigation. Learn it and live, or leave it and be damned. Well, it's a wonderful play. It's more relevant, I think, even today than it was in 1919. But what a powerful image that is for the world today, or parts of the world today. The captain and the crew have abandoned their posts. The ship with the rest of us is heading for the rocks. What do? We learn, we have to learn, and very fast to navigate. Now, Shaw, throughout his plays, had one single message in just 3 words. Think for yourself. He wanted to wake everyone up so they could realize how they were all drifting into terrible danger, making assumptions, following directions, general directions that had led them into the destruction of the First War and much else. And he said it was vital that they now started to think for themselves. Well, you might say in the present day we're still okay because there's a lot of people thinking for us, particularly in science. There are tens of thousands of scientists thinking for us, coming up with solutions to all our problems. However, just over 3 years ago, 3 American scientists published a very disturbing paper. The names are Park, Funk, and Leahy. It was published in the journal Nature. They looked back at 6 decades of published papers and patents. They sifted them out into 2 categories. One category was refinements of existing knowledge, small, incremental, but excellent improvements. The other category was great breakthroughs, the level of quantum theory, relativity, DNA. They were able to separate these 2 kinds in a rather ingenious way. They looked at the patterns of citations of these papers. They looked at the way in which people afterwards were quoting them. If you've written a paper that simply refines existing knowledge, you will quote a lot of other people's papers who you're building on, and then when you are quoted, the people who quote you will quote this great screed of people whose work you've built on. Conversely, if you come up with something absolutely fresh, when there's a reference to it, it's usually simply to your breakthrough paper. So they ran this through. It was tens of millions, 6 decades of published papers and patents, and they found in those past 60 years there has been exponential growth in investment in science, in the money that's spent, in the people that are trained, in the number of people working. However, and of course brilliant breakthroughs, wonderful technical breakthroughs if you can think of all the electronic and digital systems we use. But in terms of the number of great breakthroughs that transformed people's knowledge and laid the foundations for new developments, it's actually not increased. It's going, if anything, is going down. So something is clearly wrong. They suggested, and some people have also said, that it's because of the structure of science. It is so rigidly boxed. Scientists have so little contact with a diversity of people. They're in big research teams with each one of them has got a small part. They're rather like workers in a factory. Each one's making a little part of the unit, but nobody is getting the opportunity to stand back and see it. And that leads then to the problems of the world today, because one of the characteristics of the problems of the world today is the extent to which nobody seems able to solve them, and nobody even is coming up with any fresh ideas. It turns out from some of the people who've looked at this that this is because there's been a fundamental change in the nature of problems over the last 50 years. 50 years ago, things were broken up into sections, and if you tackled one area, one problem area, you could solve it. So, for instance, there was the problem of the hole in the ozone layer. Certain chemicals were causing difficulties, so there was legislation, the chemicals were cut down, alternatives were found. That was a solution. There was lead in petrol causing problems. Laws were done, research was done, alternatives were found, and that was solved. Today, however, it's a different situation because you can no longer separate technical problems from social problems from economic problems. The classic one is, of course, in energy, where clearly we would all like to stop using fossil fuels tomorrow. But because energy and economics are so tightly coupled, it's simply not possible for the world to stop using fossil fuels tomorrow without triggering an economic collapse. And in fact, it's worse than that because of the damage, the poor performance of many global economies. Desperate politicians and desperate investors are splashing out vast amounts of money in areas like AI. AI then has huge demands on energy, which in turn intensifies the climate crisis. And then you can also see that when you try some solutions to the climate crisis, they have knock-on effects. So, for instance, electric cars are proposed as a solution because they could use renewably produced electricity. But then we find that the scale of which electric cars would have to be produced to make a difference will require mining large amounts of often difficult to extract metals, which in turn will require energy and then will trigger off political and sometimes military crises. So you've got really a series of categories of crisis that are all interlinked. A French systems thinker some 25 years ago used a phrase, polycrisis. We're not in a group of crises where you can focus on any one group and solve it. We're in this polycrisis, and this is a category of problem that systems thinkers have invented a rather nice word for, a wicked problem. And a wicked problem is simply one that basically fights you back. It's not a kind of dead one that you just tinker with and adjust, a little bit like reprogramming a computer. A wicked problem is one that fights you back. You push it a little bit and you find that it comes back in all kinds of ways. A wicked problem is defined now as a problem with social and cultural issues. So the technical part of the wicked problem cannot be tackled in isolation. You've got to tackle the social part. It's difficult to define, it lacks a clear solution, it resists resolution due to complex, interconnected, shifting requirements. So it's not a case of making something or solving something or building. They actually defy solutions, and it's worse. Attempts at solving them can actually make them worse. Now you can see, if you look at climate change now in that perspective, you can see why so little progress has been made, because of all those interconnections, but because again and again and again people have been tackling it as a simple problem that you could take one area and solve it. I think that Scottish Government's website tells us about climate change, and then it more or less says, oh, but it's all right, electric cars and heat pumps. As if tomorrow morning, suddenly we all go out and buy an electric car and a heat pump, and that solves it. Of course it doesn't, but politicians like simple solutions. But I'm afraid to say, speaking from a scientific point, we are also trained in science to look for simple solutions. There's the example that's sometimes quoted of the scientist who wants to work out the motion of an elephant sliding down a hill. Well, the scientist approximates, instead of a hill, you have a straight line on a slope. Instead of an elephant, you have a point mass, and that makes it a lot simpler. But the problem is, in the real world, there is a hill, it's got rocks and trees on it, and there is probably an RSPA officer as well who tells you you shouldn't be doing it. So the real world problem is a wicked problem. So how on earth do we solve wicked problems? There's a few people working in the field, and it's this fascinating area that comes under this general category of systems theory. One approach to a wicked problem is do something very, very small. And the reason is, if you do something very, very small, you won't trigger a kind of backlash, but you will try a feedback, but you will maybe learn small incremental steps. Another one is to pool ideas with many, many other people who are looking at the wicked problem, even if those people have solutions that don't make sense. It was a computer programmer that told me that. He said whenever he was programming, if he got a block and he absolutely couldn't solve a problem, he asked somebody, and surprisingly, even if the person he asked came up with a solution that was pretty stupid, it actually helped him. I was trying to work out how that could be, and I thought, well, maybe if somebody gives you a stupid solution, you have to work out why it's stupid, so you get away from your own thoughts and a fresh perspective. So, two ways of approaching a wicked problem. One, do small things. The second one is try to get as many different diverse perspectives. Now, a Slovenian group working on this said that suggests that communities are a key to solving global problems, because communities, by definition, are doing things on a small scale, but there are hundreds and hundreds of thousands of communities. So you're able to experiment and get hundreds and hundreds of thousands of approaches. And also, at a community level, you can integrate all the factors. Having said that a wicked problem involves the technical aspects, involves human, cultural aspects. Well, in a community, you can integrate all those different elements and tackle it. Now, it's interesting then to apply that thinking, for instance, to energy. And I should say first of all, that again, governments for years have been giving us these simplistic approaches. There's absolutely no sign that any of them are working. If you look in a box, look at the output, electrical output of renewables, tremendous. You see it really rising like that. Only problem is if you look at the graph for the last 30 years of the output of oil, you see it's gone up by about half, and that's over 30 years of international climate COPs. If you look at coal, it's gone up, it's just about in 30 years, just about doubled. And the problem is, globally, because of the economic links and so many other links. The global demand for energy is so great that it's drawing in. It's not only absorbing everything that people can produce with renewables, it's absorbing and it's drawing in increased coal and increased oil. However, at a community level, you can really make a difference. You can, because a community-owned wind unit group of wind turbines, is actually more efficient than the grid because you can balance it. You can bring in electric cars locally. You can make hydrogen. You can power your electric cars with batteries. You could experiment even with areas like methanol. At a community level, you can get your balance. There are ideas, for instance, now in community levels, technical ideas like batteries, using electric cars to store surpluses of electricity, which of course nationally is extremely difficult to do. And there are also suggestions, a group in Belgium is suggesting that we should even look at the household as a kind of unit. And the argument is if you can get a balance on the household, then you get a balance in the community and so on. So they argue that, for instance, households, we should look at increased battery storage so the household can get its electricity in balance. Small wind turbines, small solar panels, rainwater harvesting, composting everything from the toilet. And the Belgian group are looking at ways to involve microorganisms. Increasingly, they almost argue that instead of seeing microorganisms as the enemy that we must eradicate with pesticides and so on, we should look at microorganisms in partnership, and everything in our waste, we should try to find ways of tackling them. Well, it is really, really, really urgent. I was just reflecting the time it dawned on me that there was a problem with climate change. It was the year 1986. And I remember reading an article in the magazine New Scientist explaining that the early computer models were showing that predictions that the weather for the north of Scotland was going to be warmer, windier, and wetter. I had started to notice, people in Orkney had started to notice very, very wet winter. My goodness, that was 39 years ago, and I've watched over those 39 years, given talks, but many, many speakers on climate in science festivals, and basically you can see the situation getting worse. I went last year to the Edinburgh Medal Lecture by Professor Johan Rockström, director of the Potsdam Institute of Climate Impact Research, and his first slide was 16 graphs, and there were graphs of every aspect of all kinds of aspects of the planet, all kinds of measurements, aspects of the health of the planet. Every one of them had shown this long, almost level trend for many years, only slightly, but then it hit a corner, a curve, and curve which was the prelude to an upward one. It was the exponential shape. Every one of them was going, and he simply warned that there were margins, planetary boundaries, and some of those boundaries were at 1.5 increase, some of them at 2, and he said the time had gone, long gone, for targets. You have to focus on boundaries and the consequences of crossing a boundary. That means if we actually look at the real world, as indeed the news has been telling us this year, there are all the signs, really all the signs of massive problems in climate. If you combine them with the uncertain global economy, you combine them with the global military situation, it means there is one thing that has to be done as a top priority. And it's so good to hear that language of community action and community wealth building, and that is simply community action on food. And it means action in every way, reclaiming land, looking at every conceivable product that's important. And of course the UK now is importing nearly half its vegetables, 4/5 of its fruit. It means that action, community action, disciplined, systematic action with sound financial thinking, sound organizational planning. That is this vital thing that every one of us can do. That leads into the next speaker. Huge admiration for the work of that Joe Hunt has been doing, and the way in which TSI Murray has made it possible. I think the work he's doing is the key to so much. And certainly the key to getting through, and in Captain Shotover's words would say, help us all to navigate, because we've some difficult and stormy waters ahead, and maybe the idea about food is something like a light in the storm. Thank you.